What's up, guys? So I wanted to do kind of a nonpartisan, non-biased comparison of the carbon footprint of gas vehicles versus electric vehicles. I wanted to do it mathematically instead of emotionally. And so here's my findings. So when you look at the net carbon footprint of gas versus electric, we're going to chart it out mathematically where X is going to be the miles driven and Y is going to be the relative carbon footprint. Okay. On a gas vehicle, X is going to equal Y. Okay, so the miles driven and the carbon footprint is going to be the same. Now, since we're comparing two vehicles, down here for electric, the carbon footprint, which is Y, okay, down here at the bottom, the carbon footprint is going to equal 0.6x plus 100,000. And let me tell you how we start with that math, okay? So 0.6 represents the fact that 60% of all electricity is sourced by burning coal and fossil fuels, okay? So even though when we're driving an electric vehicle, we might imagine that we're not doing any harm to the environment, we're actually creating, we're burning fossil fuel, we're burning coal just the same as a gas vehicle does, we're just doing it at 60% the rate, okay? Now, look at the part where it says plus 100,000 miles, okay? The reason why there's plus 100,000 is because when a Tesla Model S battery, the big battery in that vehicle, when it's manufactured, it is so toxic to manufacture those batteries that even before that car has been driven a single mile, that car has a carbon footprint of driving around 100,000 miles on a gas vehicle, okay? So at the beginning, the carbon footprint of an electric vehicle is horrible at the beginning. So the question becomes, when does a gas vehicle and an electric vehicle, where do they intersect at? At how many miles do you have to drive them before they have the same carbon footprint? And that's what I've got over here. All right, guys? So, the intersection, which is going to be the mileage at which the carbon footprint of electric equals gas, okay? Now to do that, I could chart it out on a graph, but I wanted to be exact. So I went ahead and I did the math, okay? So what we do is we put both equations on here, one on each side. So we have X equals 0.6X plus 100,000, okay? Now we want to get all of the X's on one side. So we subtract off the 0.6X from X. Now on line 3 right here, that brings us to 0.4X equals 100,000. And then in order to solve for that, we take 100,000 divided by 0.4. And that brings us to 250,000. What that means is that once the gas vehicle and the electric vehicle that you're comparing have both driven 250,000 miles, they'll have about the same carbon footprint, okay? Prior to 250, the gas vehicle will have a better carbon footprint, and after 250, the electric vehicle will have a better carbon footprint, okay? So here's the ultimate problem with this math, okay? It's right down here at the bottom. Okay, beep, right there, okay? The problem is that the average vehicle life in the United States is only 192,000 miles, okay? I think that it's something like average driving per year is 13,000 miles, and the average lifespan of a vehicle is something like 13 years. I don't know. I looked the stat up on Google, though. But like I say, the problem is that unless we drive these vehicles a long, long way more than we normally drive vehicles, the carbon footprint actually is better with the gas vehicles. Now, does that mean that we shouldn't switch? Okay? I committed at the beginning of this video to not be partisan or biased in any way. All right? So, should we switch to electric? Today, it will be very burdensome on our grids. The adoption rate changing to electric right now is happening too fast, and we are going to see a lot of major problems on the electric grid in the next couple of years, and we're going to see them raising electric rates to discourage use. And so you're going to have a lot of houses that are going to have no air conditioning and stuff like that. Now, we are trending towards cheaper electricity and free electricity and stuff like that. They have they haven't solved free energy, but they've figured out a way to insert X amount of energy and it outputs something like 1.5X, okay? So as that gets better and better, we will get closer and closer to free electric, free energy. And then, of course, there's other things like the building of hydroelectric, the buildup of solar, the buildup of wind energy. And in time, electric vehicles will be a great solution. I just think that right now, we are not yet equipped for it. Anyway, have a good day, guys. I hope you enjoyed it.